Good afternoon, everybody. So I'm Emma Armstrong, Sustainable Electronics Ambassador for In2Tec, and I'm here to talk to you today about how we're trying to inspire sustainability within the electronics industry. They did warn me this wasn't working. There we go. So we've been around for 40 years, designing, manufacturing and innovating in electronics, primarily flexi hybrid. We work in automotive, aerospace and a lot of other industries around the world. Reuse and recycle technology was developed 15 years ago, which is when I joined the business, but unfortunately at that time the world just wasn't ready. So reuse is a suite of materials, processes and design principles used to manufacture printed circuit board assemblies or PCBAs. And then recycle is the closed loop ecosystem that when it reaches the end of its useful life, you can actually take the whole thing apart and reuse the components as well as the substrates. Now we've been manufacturing reuse, we're now across 4 industries. And it's essentially the conductive adhesive. So the nirvana is to be able to change all substrates away from FR4 or polyamide, the types of substrates that cause a lot of problems in our industry. But the external part actually has a QR code identifier, one to make sure that it doesn't go through the traditional processing, but also for identification on the PCBA itself. So the components, you can see whether they've been first life, second life, how long they've been in use and so on. Now one of the major changes, I'm not touching this button, sorry, can you move on? Thank you. One of the major issues in the electronics industry is the processes that we use and the materials that we use to manufacture with. If we look at this stuff here, so the green boards that you're traditionally used to seeing in your mobile phones or home electronics perhaps, this is fiberglass. It's a man-made substrate, woven fiberglass with a glass polymer resin. It's hideous to make. It's hazardous to burn, and when you put it in the ground, you can't do anything with it. The same is true of this, which is polyamide or PI, and both of these substrates are a subtractive process. So they're clad in copper. You then identify where you want your circuit traces, you etch everything else away, you place your components on with a solder, and then they go through a high heat reflow oven, and that's how you produce your electronics. Then you have printed electronics, which is the space that we've operated in for 40 years. And this is an additive process. So you have your substrate, you plate a carbon seed, you then print on a conductive ink, so whether that might be a silver or it might be a copper. You bond your components on using conductive adhesive, and then it goes through a curing process. So it's organically more sustainable, but irrespective, with traditional methods of manufacture, all of the electronics that are out there in the devices, the headsets, what I'm speaking on, the mobile phone in your pocket, no matter which you choose, when they reach the end of their useful life, you can't do anything with them. Now we are a very, very demanding species. So, you know, when you think about the humble remote control, 700 million of these are sold around the world each year. 800 million white goods. And every single second, somewhere around the world, 127 new devices will connect to the internet. It's okay to be a demanding species. We need advancing medical technology. We want the next level of functionality. We want to be able to, you know, protect our homes. But we just need to find a way to do that is more sustainable than it is today. With the current recycling process, as I've said, it's impossible to recycle this stuff. If you want to try and get components back, which is the primary action within reuse and recycle, you have to desolder them. And to desolder them, you either need to use really high heat or high mechanical force, or both. And when you do that, the component is then useless because you've broken it. With regards to even the printed electronics, you'll often tear the substrate before you actually remove the component. And even if you can get the component off, it's contaminated with all of the materials and inks that you've used, and you can't make an electrical bond the second time around. So what happens is, when it's all collected to go through what we consider to be a recycling process, all we're looking to do is to burn it to get back as many precious metals as we can. We obviously take out the housings, so the metals, the glass, the plastics, they're all reclaimed. But the electronics themselves simply go through a shredder. Now, all of our waste in the UK is shredded, and then it's shipped off to mainland Europe for smelting. And that smelting process is significant CO2e when you look at the temperature, the time it takes, and unfortunately, this toxic stuff here is what's used to fuel that furnace. Now, any which way you look at this, all of those components, all of the resources that we've mined, all of the energy that we've spent to manufacture, and over 95% of the value in this board is in those components, everything is lost. But we don't do it because the cost to recycle it just vastly outweighs the financial gain. You move on, please. 61.3 million metric tonnes of e-waste was generated around the globe last year, and only 17.4% of it was collected, documented, and went through the process that I've just explained. So that means that over 50 million metric tonnes of that e-waste is somewhere on this earth. We've got a trajectory because of the increase in demand, because of the way that we are producing electronics. We're going to be at 750 million tonnes of this stuff on Earth in 5 years' time. And it is toxic. It's got chemicals that are within the top 10 for concern, human health concern. So not only does it leach 1,000 different substances into the earth, air and water table, but it causes significant harm. Children have been known to have cardiovascular issues. It causes liver damage. It causes stillbirth, miscarriage, liver damage. The list is just endless and it's shameful. But unfortunately, manufacturers don't do things for the good of the planet unless something positive hits their bottom line. And that's what reuse and recycle has been designed to do. So just in that 61 million metric tonnes of e-waste that we generated last year, over $60 billion of recoverable components were wasted. And now that's only been calculated on the expensive stuff, the microprocessors and the chips and the PICs, etc. Everything else, we burn it. Or we chuck it away. Or it's probably in your drawer. I'm sure you've got mobile phones and things at home, remote controls that you don't know what to do with them. In terms of the carbon, clearly we're a very polluting industry. Our industry is responsible for over 4% of the global GHGs. This stuff here has been used for over 70 years. It's trusted, but more importantly, it's cheap. The characteristics of it, i.e. the UL 94 V0 rating on it, means that you can't burn it, and the properties that allow you to run very high power are actually only needed on less than 10% of the electronics that we manufacture around the world, and there are still alternatives. They just cost a little bit more. In manufacturing how much of that we need on an annual basis, 140 million square metres at 19.3 kilograms of CO2e per square metre creates 2.7 billion tonnes of CO2e. Now that's the equivalent of driving a combustion engine car around the entire circumference of this earth over 546,000 times. You then add the components, and the components then take it up to 11.3 billion tonnes of CO2e. And that's just on this type of substrate. There are many. The problem is that, unfortunately, people like FR4 for the properties, for the fact that it's been used since the 50s, and also because it's really low cost. Okay, so when we looked at the opportunity to remove all barriers to entry, we included the fact that we need to be able to use substrates that people trust and use today. So that's what we do. You can use FR4 through the process. When you've then finished with your electronics or your device has gone to a processing facility, we take everything apart. Everything comes off this. They are stress-free, they are uncontaminated, and so is your substrate. So every time we don't remake that substrate, we save that 2.7 billion tonnes. But more importantly, every time we reuse just 10% of components, we save another billion tonnes. in terms of the opportunities for the circular economy, I want to use the example of a laptop with what I was just talking about. So I don't know about you guys, I work on a laptop, but unfortunately in my career I've been through many, because the average life expectancy of a laptop is between 4 and 5 years. Now 75% of the embodied carbon inside electronics comes from the components, and the components are designed to withstand 25 years of life minimum. Some of them will go on indefinitely, and some do deplete, like LEDs. You know, they have a passive discharge. That light will eventually fade. But the majority of components will go on and on and on and on. So when you consider perhaps making a laptop today with the reuse materials, and you can use the FR4, outside of the way we connect with it, outside of the speed, and outside of the memory capacity, you can actually go on and make 4 brand new laptops with the 82% of components that exist in the laptop today. It's a no-brainer, right? Because every single time you take back these components and substrates, they are carbon-free and they are cost-free. This is case study evidence of one customer who, fortunately, were able to achieve Nirvana on day one. So this is an LED light bar, and it's used in commercial lighting. So the type of things that are probably in every one of your, at least business buildings. We were able to change from FR4 to a recycled aluminium immediately, because the heat dissipation properties and the characteristics of the recycled aluminium made the product itself more efficient when it was running. Being able to do that, the combination of changing to the reuse materials, changing the process and changing the substrate allowed us to reduce the CO2e in that first life manufacture, the very first time we build one, by 62.5%. And every 1 million of these that we build, we save 314,000 kg of CO2e. And the customer also realises a net benefit to their bottom line. Now that's based on only using 10% of the components. If the first life, they're only been used for 10 years, even those LEDs can be reused. Use half of them, they save £250,000 the next time around. So, okay, why aren't we doing it? As I said, you know, we've been around for a really long time. We had a project that we worked with an automotive manufacturer, and the manufacturer made a mistake, and it was a very expensive mistake because you couldn't get the components off again, so everything went up in smoke. And we decided to start thinking about, you know, what this really means. How do we make sure that when our kids need medical technology, that they are actually going to be able to access it? Because if we don't stop, they're never going to be able to make anything. Why? Because we're mining it all. You know, gold that we use in electronics, the yield is depleted by 23% in just the last 6 years. They're not going to be able to make anything. So the way that we look at this technology and the opportunities that we're giving to OEMs, contract manufacturers, I don't want to rule the world. I don't want to get rich. This isn't about me. This is about my 6-year-old and yours and his children. You know, we will, for very, very little money, help people to implement this themselves. They don't have a big investment. They haven't got to change their manufacturing equipment. Everybody has the opportunity to be able to use the materials that not only allow them to extend the useful life of products, because you can do this on one component. You don't have to do it on all. But when it does reach the end of its useful life, you can take it all apart again and start again. So when the manufacturer takes back all of that value, and they will want it back, so they will incentivize you as consumers, they make a lot more money, they make the product for less, we pay less, the planet pays less. Now, we're on stand H19. If you have any questions, I apologise, we ran out of time. And we're also demoing this. So if you want to come and see me, that's where I'll be.
Thank you, that was extremely insightful. One thing for the audience, what can each person do to help recycle more electronic waste whilst we're getting to the interchange? Is there something that everyone here needs to know as they go home tonight?
Well, the problem that you have is even if you do the right thing and take it to a WE recycling facility, all that will happen is, as I've just said, it gets shredded. So we don't have the benefit like we did with plastic carrier bags or plastic straws of boycotting. We don't. What we need to do as consumers is try and make producers take responsibility and push the government to push legislation, which is where I work primarily. That's what I do.
Thank you. So policy driven. Thank you very much, Emma.